Okay, I hope audio works and people can see stuff. I have no idea. State machines. Can I emulate XState does? I'd need to look up exactly what XState does to answer that. But probably. Though that might require some looking up first. Right. Um, do I get a proper documentation here, or is that just all? Yes, I know what a state machine is. Yeah. Anyway, one question. How's the audio? Is it loud enough? Okay. I'll also need to figure out what exactly the latency is. I have it on low, I believe, but I don't know what that necessarily means. Yeah, low. But we'll figure that out. Okay. So, I mean, state machines in general are always just we're gonna have some starting states, some end states. Potentially, not every state machine is necessarily terminates. And we're going to have rules on how to transition, right? So if we think about it, we'd need to have some way of defining our states, right? So we'd probably have some sort of start somewhere. And then probably some transition on X, which goes to another state. And then we'd have another state here. And so on and so forth. I mean, that's basically all a state machine is a set of states and a set of transition rules. Then the question would be, how does this interact with React, right? So I would imagine that we use it kind of like a useState, but instead like a useState machine. Basically, the idea is you can have more explicit error handling than simple booleans and enums, yeah, and avoid infinite state that great overlay. It's just putting an icon right over text. Infinite state that complicates error handling. You can use a state machine for that, but a state machine comes more from theoretical computer science. It's another approach on how to model software. And error handling can be considered a piece of software. Whenever your application running, whenever the program's running, it has some sort of state. And technically, in the real world, every state machine is finite, because eventually the power's gonna cut out. No matter what you do, your machine's gonna stop at some point in time. But you can write programs that are technically intended to be running forever, like in a while loop. Like you can imagine a server thread, or yeah, let's go with a server thread, right? That starts here with init as the first state, then goes listening for connections, then on a, I'm going to do that like this. It's not the best way to write it, but we can then do an on-con. We could do handle con and then go back to listening for con. We wouldn't have a final state here, right? We'd just be looping over this forever until the server shuts down. So it's not necessarily a bad thing to not have a final state. But if we're talking about form validation, then you do want a final state, yeah. Because otherwise you're not gonna, your form's never gonna complete. So this is Chomsky hierarchy related stuff from comp science, models of computation. Yes. Assuming I remember the Chomsky hierarchy correctly. Which I should. No, it's not. Because that's regular expressions. Regular expressions can be, well, not just regular, but they can be modeled as state machines. Grammars, but for example, where it is important is in computational complexity, right? When you're talking about Turing completeness, if some sort of computational model is Turing complete, what we like to do is to transform it into a Turing machine, and the Turing machine is a state machine. We'll always have some sort of memory. We may not be allocating memory, so we might be running in fixed size memory. But if you don't have memory, you have no data. And if you have no data, you're not doing any data processing, and the entire point of an algorithm is to do data processing. But yes, Turing machines. Okay. I need to get used to reading the question out loud, probably. That's probably good etiquette for a stream. So a Turing machine is a hypothetical state machine with infinite memory. Yes. So a Turing machine traditionally is a tuple of, we have states. Well, we have states, we have start, we have a stop state. Then we have rules on transition, and then we have a memory band. And that can be imagined like a tape, but this is the initial memory. And plus a infinite processing memory. So usually what happens is we can imagine it as a band of some symbols, characters, and the machine is going to be always at some position. Its current pos plus a state, and then the rules will can read the signal. So, and we can do the following things. We can read current pos, write current pos, move left, move right. This is basically all we can do. And we can move as far to the right as we want to infinity, and as far as to the left as we want to infinity. And so basically your rules here are going to be always going to take the current character, current state, and from that we're going to have some sort of decision on what we do. Are we going to... Oh wait, stop. That's another command. So technically we don't need a stop state. But that's basically all a Turing machine is, and the reason a lot of people like to transform computational models into this is because it's incredibly simple, right? There isn't much going on. You don't have registers like you have with a computer. You don't have complicated control structures. No, that's as long as you can move to the right, to the left, read and write the current position. That's it. Often people like to extend the bands to not only work with one band, but that you can just create new bands ad hoc, etc., because it makes it much easier to handle mathematically, but you can prove that you can transform one of them into the other. I hope that explanation made sense. Okay. So if we think about how we want to use this from React, we probably want some hook, right? Like use state machine, which takes a specification of some sort in, and then returns some sort of object that allows us to process, right? Transition. We have a transition rule. We just saw it with the Turing machine. We have some sort of input that is some sort of event. Let's just say it, transition on event. And that's going to return a new state. Or a new state machine, right? That's basically all it is. Obviously, this should cause a re-render if we're talking about React. And the typing here could be interesting, technically. Maybe we could look at the typing, though I suspect that to type this properly could be kind of nasty. We'll need to see. But I think that's it. I mean, XState has some other features here, it appears, like parallel states, which would be just a fork, but you need to join them back together eventually. You can always model parallel states without parallel states in state machines. It just makes the state machine much larger, usually. There's also non-deterministic state machines. So usually, if you're in state A plus some input, or however that is modeled, you always go to a specific state in a deterministic one. And then there are non-deterministics ones, where you have possibly two rules that move to different states. So you have a fork that could be kind of also considered like a parallel state. You're not sure in which state you are now. You might be in B, you might be in C, but you know you're either in B or C. Oh, sorry, I knocked my microphone. But you're either in B or C. And you can transform these into this form. It just explodes it a lot. What else does this have? It has transitions and events. Eventless transition always delayed, I guess, on timers. Okay. Self transition. Okay, yeah, sure. Okay, that's about the parallel states, I guess, and well, that's about it. Sure. So what was that? I wanted a command line. You. I think I remember that right. Now, it's been quite a while since I wrote React, so I'll definitely fumble a bit, but we'll see. Okay, you're asking, seems like React's free rendering mechanism local versus global state and async ops can be complicate things. Also, XState seems to rely on mutable stuff usually. Wonder how it handles its React's variant. Usually, I'd always model state machine immutable. Because the way we can always model it is as a function, right? Essentially, it's just a function that takes in a state and an event and returns a new state, right? And the state can be just a label. That's just the name of the state we're in. There's nothing to mutate necessarily. Obviously, React itself being full of mutations, this will be a state transition in React here. But yeah. Now, local versus global state. It's not really an issue. You can always stuff it into a context if you want a global state. But contexts have other issues, mostly that they're hidden complexity, in my opinion. Asynchronous operations can indeed be a problem, though we are in luck that JavaScript is actually running single-threadedly. We don't have true concurrency, which means the order of events is we're always going to finish a transition before we can start the next transition. So if two transitions get started on the same state, for example, we can just refuse to do one of the transitions. State machine. Maybe has one TypeScript. Big. Okay, so let's start with dev server. That's not the right browser. Yeah, it is. PNPM? I'm not familiar with that. It's a different package manager. Yeah, sure. Okay, and new console, and I do know that I want to install White Type, I believe it's called. No. White plugin check. White plugin checker. Okay. Hi, Harash. Okay, and then we go to our white config and I am indeed from Germany, and my real name's Daniel. Okay. So we should get now actual compilation errors, which is always nice. Made this mistake in my last video. Let's just delete everything here. And it does indeed work. Okay. So. Then if we're talking about our state machine, right? It should be a hook of some sort. But we also know we need some sort of type. Yes, that is indeed Neoben. So we talked about how it is usually a tuple and then a transition function. So let's start just with the types. So we have a state machine which has a list of states. Let's just make it a set of string. It got a start state, which is a string. Now, we could try to type this in a way that we enforce that this state is actually part of the values in here, etc., but that is going to be more complicated and potentially janky because the TypeScript type system is not necessarily always the best. And then we have our rules. And how should a rule look like is a thing we should think about. Because remember, we want a function that comes out of this. That's a transition function that takes in a state and an event and returns a state. That should be the core of our state machine. So a rule always going to have the current state, the next state, and an event of some sort, right? So state transition rule must be of some sort. From, which is a string, and I'm going to retype the string as a state because I want to write this more expressively. So it goes from a state and it goes to a state. And we have some sort of condition. Now, should this be a free-form thing? Should it be a string? I'm not entirely certain. Let's go with, I call it a when and make it a string for now. And then we have a set of state transition rules. That's what I called it. Right? I don't know if we want an end state or if we can encode that differently. But let's worry about that later. One thing we want to do is we want to create this function somehow. So let's do a init state machine. We're going to take in a state machine as an input. And we're going to return this function. But for that, we need to establish some things. So actually, we're going to return the start state and this function, however this function looks like. Transition function. I just call it transition. And then we can define our transition function here, which takes in a state and a event returns a new state. And we don't need this thing anymore. And I won't be doing React for a while because I'm just going to specify this thing. The reason I'm going to do that is this allows us to test if we were writing tests, which I'm not going to do. But if we were writing tests, we could test this thing independently of React, which is always nice. And then we'll see how we can wrap this to make it work with React. So we can transform our, we can create a map for convenience from our spec. It's going to be an empty thing first, and then we can go for through our rules in our specs. So for it's a set, it doesn't have that. Okay. State rules should go with spec. So I suspect this should be an off, right? Is it telling me a set is not iterable? No, it's telling me I forgot a let. Okay. And then we can just fill up our transition rules here with a rule. Right, this is JavaScript. It doesn't do that. Keep forgetting that. Let's do a double map. So basically the structure I'm going to look for this thing is going to be it's going to be current state, and then please current state, and then the when state, like so. That's the thing I'm looking for. So we can do rule dot from rule set, and then if rule set undefined, we can simply make it an empty object. And finally, add this to the transition rules. Like so. And then we can just fill it in here. So our rule set when rule.when becomes our rule.to. Right. That's wrong mode. So what's the issue here? Has implicitly any. And let me type this. This is an object that has key strings and has an object key string, like so. Okay. What's the issue here? That's okay. And then all we need to do is check lookup in our table here. So transition rules state That's rules for this state. And then if rules for this state undefined, we're going to return the current state. We're just going to declare implicitly that any rules that are not specified don't change the state. And then we can do, then we know that rules is defined, and we can access here the event. And if new state undefined, same thing. This means we're never leaving the state, and this means there is no edge out of the current state. Otherwise we're going to return the new state. And this is technically it. This is a full state machine, more or less. We could say that we're not going to only return state, but we're also going to return state and is running as an Boolean. And I need to use different brackets here. And the reason for that is this allows us to encode the running state if we're still running. Because then we can add a end state. And in our transition rule, if state equals to the end state, we're going to refuse to change the state. And instead of returning just new state, we're going to return the new state, and we're going to do the check if that state is the end state. And then we have end state encoded as well. What are errors? Right, this should be true. And in this case, it's going to be state equals and in this case as well. Right. Okay. Theoretically, we have a fully functional state machine. By the way, if anything I do is confusing or I go through something too fast, please just tell me. And this returns a function that's defined as an actual type, state transition function, which takes in a state event string and returns state boolean and you go and return a state transition function. And a start state. And it's okay. What's the error here? State only refers to type, but being used as a value here. Okay. Right. And then it be just a matter of actually using this thing in a React context. So use state machine. We're going to take a React hook in here. It's going to take a machine state machine as an input. And then we're going to do a use state here. Can actually just skip this and use a use reducer on top, because the way we wrote it, we should be able to just use a reducer if I remember how to do that. The reducer function, and then the why initializer arg? Oh, because okay. So it's not quite what we want. Because we have two steps. I was kind of hoping we're going to give us a initial state and the reducer, and that's it. But maybe I'm reading this wrong. No, that's a function, yeah. Wait, reducer without what? I'm just gonna use a state. Same thing anyway. Under the hood, it actually is the same thing if you look at the React code. So we're going to define our state machine here. That is init state machine. And we're going to input the machine in here. That's going to return a state and a rule, the rule. And then we can that's actually all we wanted to do. So we can just make this easier on us. Okay. Then we have here state, a rule, then set machine. And we're going to return state and rule, though we want to return the final status as well, right? So we can then also return rule dot, not rule, machine end state, state. So technically we didn't need the stuff up here. We're thinking about it. Set machine, yeah, okay, that's fine. But we don't want to quite return this rule. We want to actually return something slightly different. Because we want to invoke this set machine. So update, let's call it that. Let this be a function. And that. An update takes an. It's much easier if I do it this way, actually. Update, and this is a state transition function. And we're going to take in a state, new state, event. We're going to call a rule of new state, sorry, of current state, new state, event. I don't know why I called this. We don't want this a transition function. It should just take an event. Because we have the state already. It's the current state. Then we're going to return the event. That is set state. And state rule. Sorry. Like so. So we want to keep our rule here. Right? That's all we need to do, and then instead of the rule down here, we're going to return the update function. And I called it set machine, not set state. String boolean is not assignable to type string. I'm not trying to assign a string. Oh, right, that returns a... There we go. Like I said, we technically didn't need to encode the end state in here, because we can always check the end state ourselves. Arguably, this shouldn't be an array, but an object. So let's make it one. Running. Okay. And we can just use this inside of Frag now. Hopefully. So we can define a very simple state machine. Let's just actually call it start. Start state. And why am I not getting any type information here? Because I already messed up. This is start state as well. There we go. And let's just call it start then. And then we have end state. Let's call it end. And let's do like... I don't know. What's the state machine supposed to do? What do we want to solve with this? Like a traffic light's kind of boring. That's kind of the only thing that comes to mind right now. Oh, my indent is... Okay. Let me fix my indents. Interesting that you think this is correct indenting. There we go. Okay, then I guess we're going to... We may do another one maybe later. Traffic light's fine. Then we've got our rules, and our rules are a set, actually. Because I made it a set. And we got our states. So, states is a set of start and red, green, and orange. And this is also a new set. And let's go and look at how we defined this. An object with from to 1. There's no reason this should be needs to be a set, because JavaScript doesn't do this anyway. But let's stay over here. Okay, so we have a rule from start. We technically could, we don't need start technically. We could just start on a color directly. We go to, let's say we go to red when init and then we can copy this, paste that in here. We go from to directly to green, right? From red? I should know, I do have a license, but I believe we go green, orange, red, green. Was there a very short orange period? I don't remember. Doesn't matter, our traffic light's gonna be this way. From red to green when time take, right? And then from green to orange. Orange. On time take. Now, what I talked about with the typing, we could make TypeScript enforce this, that we can only put in start here if it's one of the known sets, and that start state can only be one of these states, and end state can only be one of these states. Same with the two. We could enforce that. But the typing for that is going to be kind of nasty and super complicated. And I forgot commas everywhere. And from green, from orange, we go back to red. On time tick. And we want an end state, right? Let's say that we can only shut down the traffic light if it's red, because otherwise it's not safe. So let's go from red to end. And let's call it shut down. For whatever reason. Okay. So we get our values here. That is the state, the is running, and the update function. We can then simply display here the current state. And let's see if that even works for now, right? Okay, let's get rid of errors. It doesn't like that we use reducer here. What's your problem? A function who's must return a value. Indeed, the wrong language. Again. And then can return a state here. And it doesn't like that we are never using the running and the thing. I'm just making it shut up, basically. And okay, so we then start. This makes sense. That's all what we wanted. Then let's add buttons. So we have a button. Which has an on-click, and this on-click's just going to do a update, and it's going to just emit the event in it. And then this will just be init button, and time tick, and shut down. Tick, stop. And do we want to do anything else here? Not really. So if we hit init, we are on red. If we hit tick, we are on green. If we hit tick, we are on orange, tick, red, etc. And this loops forever. If we try to init again, nothing happens. If we try to... We were on red. If we reload this and we try to hit stop when we're not on red, nothing happens. And if we hit stop on red, we see we terminate. That's basically all there is to a state machine. That's all Xcode does, Xstate does. It has a bit more fancy wrappers around it, but that's really it. And let's also output the running, and then we can delete this. Right. I don't know why running is not being displayed. There's a rule. There's the hook. Right. Oh, because React is being React again. Is that why? Yeah. And I flipped them. Running should be obviously the other way around. And we can say running state okay. Right, so we can tick through this again. If we stop, running goes to false, and now nothing we click does anything anymore, because the machine's always gonna be stuck in that end state. Yep. So there really isn't much of a lot of magic behind state machines. A lot of frameworks like to make it obfuscated or complicated. And from this, we can also see that React itself is kind of a state machine, especially if we look at the use state or the use reducer hooks. All they do is kind of have the same pattern here, right? Especially if we look at the use reducer. It's also just a rule that takes in the previous state plus something and returns the new state. And same thing with the use state technically, the way it works, because you can also consume the previous state here if you want. Well, technically here. Right. Neat. So, I hope that was clear. Got any questions? Okay, taking that as a probably not. Good. That's okay. It'll be uploaded, so you can just comment underneath. Alternatively, you can ask me in my Discord, and no, those are the only options. And otherwise, I'm kind of glad this all works and that I wasn't just talking to myself. And I think I'd stop here then as well. I'll probably do this again and see you around.